Hello guys, we make a start. Paper 4 of February March 2024. So we look at the very first question. This is about extraction of iron in the blast furnace. Okay, so we look at the very first question. Iron ore contain iron 3 oxide Fe2O3. A blast furnace is used to extract iron from, you see the formula. Equations for some of the reactions in the blast furnace are shown. So we can see the equations. These are some of the equations, not all the equations. Now we go to the equation. Equation 1 shows the combustion of carbon in the blast furnace. Name the substance which provides the carbon for. Okay, so the charge in the blast furnace contain three things. Carbon is from coke. Okay, calcium carbonate is from limestone. So limestone is mainly calcium carbonate, and of course the ore itself, hematite. Okay, so that's what the charge is made of. So response to our question: name the substance that provide the carbon. No, none other than coke. Okay, so coke, it is coke from the destructive distillation of coal, which is mainly carbon. Now state the purpose of the combustion of carbon in the blast furnace. In other words, this first reaction, why is it taking place? Note that this reaction is actually exothermic reaction. It means it's going to release a lot of heat, which is needed for the reaction. So the combustion is an exothermic reaction to provide the heat needed the for the extraction. Okay, so you say it takes exothermic reaction that provides the heat needed for the reactions. Okay, needed for the reactions in the blast furnace. All right, so what's giving you your answer? Because they ask what's the purpose? To provide the heat for the reaction. Now we make progress to B. Iron 3 oxide, we see the formula in ore. In iron ore is converted to iron when it reacts with carbon monoxide. Okay, so carbon monoxide is the reducing agent in this process. Now calculate the percentage by mass of iron. Okay, so each time you calculate the percentage by mass, you want to first of all get the m arrow, and the m arrow in this case is the formula mass of iron 3 oxide. So the first thing you want to do is to know the number of atom of iron that is present. So number of atom of iron that is present is 2. You from the formula multiply it by the A arrow, relative atomic mass of iron. Get it from the periodic table, that's 56. Now you add that to the number of atom of oxygen. Number of atom of oxygen is 3. Multiply it by the A arrow of oxygen, which is 16. You get that. So if you do this, 2 times 56, you get 112. You add it up to 3 times 16, which is 48. Okay, everything add up to give you 160. So the m arrow of iron 3 oxide is 160. Okay, so to do the percentage of iron, you do the mass of iron over the total. Okay, so you are doing 112 over 160 multiplied by 100 over 1, that's percentage. So you could be asked to calculate the percentage of oxygen. Okay, so calculating the percentage of oxygen, you are doing this over the total. Okay, so that's the way to calculate percentage by mass. Now you are okay, so quickly let's punch the calculator. 112 over 160 multiplied by 100. What do we have? Okay, so this is 70. You could do 70.0 to a three significant figure. Okay, so that's great. We make progress. State the name of the iron ore which consists mainly of iron 3 oxide. We have mentioned that the extraction of iron is from hematite. Okay, so our response, hematite. Okay, so hematite is the ore of iron. So we are writing hematite. Okay, so hematite is where iron is extracted from commercially. Okay, describe how carbon monoxide is formed in the blast furnace. Okay, so carbon monoxide. Now, this carbon in the blast furnace, the first equation in the blast furnace actually happened. You know, blast furnace is a tall tower, and hot air is blown into the furnace from the bottom, and this first process is will happen, and as it happens the carbon dioxide rises up. As it rises up, it's going to combine with more carbon as it goes up. So you are saying carbon dioxide rising up to combine with carbon, and we will have carbon monoxide. Okay, so you could balance the equation. And so this process is actually an endothermic reaction that takes the heat from the first process, for it to occur, and it's good for the system because the main extraction, which is reduction, is also an endothermic process that needs a little reduction of heat. Okay, so describe how carbon monoxide is formed. Our response, by the reduction of carbon dioxide with coke. Okay, so we are saying by the reduction the reduction of carbon dioxide with coke. Okay, by the reduction of carbon dioxide with coke. That's great. Now write the symbol equation to show the reaction that occurs when iron 3 oxide is converted. Okay, so this is the reduction process. We've mentioned before now that the reduction process is with carbon monoxide. So you are doing iron 3 oxide. You have seen the formula, iron 3 oxide with carbon monoxide to give you carbon dioxide. So carbon monoxide is oxidized, and iron 3 oxide is reduced to iron. Okay, iron 3 oxide is reduced to iron. Now your ability to write this equation correctly, correct reactant, correct product, 1 mark. Then we will need to balance the equation. Okay, so let's start by balancing the equation. Perhaps we could put 3 here. 3. Okay, so that makes the carbon to be 3 on the product side. If you put a 3 here, the carbon on the reactant is also 3. Okay, so we are left with oxygen on the product side. 2 times 3 will give you 6, so we have 3 oxygen plus 3 oxygen, that's equally 6. Okay, so we are left with iron, so we put a 2 here. Equation is balanced. So balancing the equation will give you 2 marks, and your ability to write the equation correctly will give you balancing the equation will give you 1 mark. The ability to write the formulas on both sides correctly will give you 1 mark. That's how you earn your 2 mark. Now name the chemical process which happens to iron when, okay, so that's what we've mentioned before now, that the entire process is reduction. Okay, you know that iron is extracted by reduction process with coke or carbon monoxide. So what you are writing here is just reduction. Okay, reduction. So the process is just reduction. Now state the type of reaction shown by equation 2. So let's go back and see what equation 2 is. Oh, equation 2, you know, each time you have just one reactant is going to be a decomposition reaction, because that one reactant is going to break down to its components. Okay, so this time around is breaking down thermally, so you say thermal decomposition. Okay, thermal decomposition. If it's electrolysis or electrically, we say electrolysis. Okay, but this time we are doing thermal decomposition. Okay, so thermal decomposition reaction it takes. Now we make progress to the next question, which is DI. Explain why the reaction in equation 3 can be described as an acid-base reaction. Okay, so you know that there is an acid-base reaction in the blast furnace. Reason being that calcium oxide is an oxide of metal, and you know oxides of metals are bases. Silicon 4 oxide is oxide of a non-metal. Silicon is a non-metal. Oxides of non-metals are acidic or acids. So you're having acids plus a base to give you salts, and that is why it is a neutralization reaction. So what you are writing is that oxides of metals are bases, or oxides, let's write that oxides of metals are bases, and calcium oxide is a base. Okay, while oxides of non-metals are acids. Okay, so we are saying silicon 4 oxide, silicon 4 oxide is an acid. Okay, therefore acid plus a base reacts to give a salt. Okay, reacts to give a salt which is called calcium silicate. Okay, reacts to give a salt, calcium silicate. Okay, So the product at the end of the day is calcium silicate. So the basic idea is that your ability to identify that calcium oxide is a base, silicon 4 oxide is an acid, is that is what is needed in this equation. I mean in this question. So whichever way you respond, the key idea: can you identify that calcium oxide is a base, silicon 4 oxide is an acid? That gives you your mark. All right, so we are making progress. Now state the chemical name of, I've mentioned it before, silicon 4 oxide. That's how it is. So you are saying silicon what? Silicon 4 oxide. Okay, silicon 4 oxide. Okay, so we have silicon 4 oxide. Then the common name given to calcium silicate in this process, we usually refer to it as what? Slag, right? We call it slag. In other words, the impurity, slag. All right, great job. Aluminium cannot be extracted from its ore using a blast furnace for simple reasons. State why aluminium is not extracted from its ore using a blast furnace. Is because carbon is less reactive than aluminium. Or you could write it the other way, that aluminium is more reactive than carbon. Aluminium is more reactive than carbon, or you could say that aluminium is higher in the reactivity series. Okay, aluminium is higher in the reactivity series, or you could state the converse, the opposite, by saying that carbon is less reactive than aluminium. Carbon is less reactive than aluminium, or carbon is lower in the reactivity series. Okay, so whichever way you put it, or you are trying to paint is that aluminium is more reactive than carbon. Aluminium, you can't just say aluminium is more reactive and go away. More reactive than what? More reactive than what? Please mention that is more reactive than carbon. More reactive than carbon, or carbon is less reactive than aluminium. All right, name the process used to extract aluminium. All elements, all metals higher than carbon are extracted by electrolysis. Okay, very reactive metals are extracted by electrolysis. Okay, very reactive metals are extracted by electrolysis. This is because it requires more energy. Higher energy is needed to be able to remove, as it were, the metals from their ores. Okay, so that is that. We're making progress. Both iron 3 oxide and aluminium oxide contain metal ions with a +3 charge. Write the electronic configuration of aluminium. Please note that anything ion will always have a stable electronic configuration. So for aluminium, it's meant to end with 8. So aluminium is element 13. So if it loses 3 electrons, we'll be left with 10 electrons. So the first shell will take maximum of 2 electrons, The second shell takes a maximum of 8 electrons, so you have 2 8s, 10 electrons. Okay, the last shell would have lost all 3 electrons, so you are left with 2 8 10 electrons. Great job. Deduce the number of protons and electrons in. So if you go to the periodic table, you'll find out that the ion is element 26, so it means it has 26 protons. So let's see this ion. So this is ion, you are looking at this. Okay, 26. So it has 26 proton. Okay, so let's go back to our question. Rotates. So here we are. Okay, so number of proton, obviously 26, as we have seen from the periodic table. So you have 26. Then we look at number of electrons. It has lost 3 electrons, so minus 3 electrons. 26 minus 3, you have 23. Okay, so you've done great job. So look forward to seeing you in our next section, where we'll answer the subsequent questions, question 2 and so on and so forth. So see you guys. Great